the last thing with absolute values have to do with how to find X and Y intercepts. And this is going to be true for, again, any function, but since we're kind of working with absolute values here, this is what we're going to be doing. Okay? So when you are finding the X and Y intercepts for an absolute value, so if I just took a graph, and I'm not going to sketch this exact graph here, but if I just looked at a graph here, okay, I have how many Y-intercepts? You can only have one. Will you ever have an absolute value function that does not have a y-intercept? No, they're always going to have a y-intercept, right? At some point, it's going to cross that y-axis. Okay, what about x-intercepts? How many? I have 2 here. Is it possible to have just one? Yes? Is it possible to have none?
Yes.
Yeah. Okay, so be aware of those situations. In each case, when you are looking to find the x and y intercepts, the easiest one is probably going to be the y-intercept. Okay, so to find the y-intercept occurs when x is what? And it's for all functions. 0. So if you just let x be 0, and then you evaluate the function for 0, okay, meaning you take f of 0, that's going to give you your y-intercept. Okay. Now, to find the x-intercepts, what's going to happen here? X-intercepts occur when what is equal to 0? The y, right? So if you set your equation equal to y or equal to 0, then solve, you're going to get your x-intercepts. Might be 1, okay, it might be 2, or it might say false, meaning no solution, which would be no x-intercepts. Okay? So if you're taking a problem like this, right, and you're looking to solve this by hand, I'll show you by hand and on the TI-89. Okay? The first thing we could do, the y-intercept would probably be the easiest thing. So we're going to take our function and evaluate for f of 0. So if we took 9 times the absolute value of -4 times 0 plus 3, all minus 5. And if we simplify this, we get 9 times the absolute value of 0 plus 3 minus 5, giving us 27 minus 5, or 22. So our y-intercept is 0, 22. Okay, and then to find the x-intercepts, okay, what we're going to do is set this equation equal to 0, and then solve the resulting equation. So if we took 0 is equal to 9 times the absolute value of -4x plus 3 minus 5, what we can now do is solve this. Okay? When we solve an absolute value equation, we look to isolate the absolute value expression. So we're going to undo all the operations, giving us 5 is equal to 9 times the absolute value of this whole expression. Divide by 9. Okay? And so here would be our equation. Once we isolate the absolute value from this, we now split it into 2 equivalent equations. Okay? I'm going to write those equivalent equations up here. Okay? So in each equation, we start with the expression. So I'm just going to do this in 2 separate stages here. In each side, we start with whatever's inside the absolute values. On the top one here, I'm going to set it equal to what was given, 5/9. And then I'm also going to set it equal to the opposite of what was given. Again, because when we look at the definition of absolute value, it's either a or minus a, depending on whether the value originally was negative or non-negative. Okay, so if we work to solve this, subtract 3 from both sides. Subtracting 3 is like subtracting how many ninths? Okay, so if we subtract the 27 ninths from both sides here, we get -4x is equal to -22 ninths. Dividing by -4 is like multiplying by the reciprocal, -1/4. Again, sometimes instead of dividing, okay, it's easier to think in terms of multiplying by a fraction just to make canceling easier. So here those cancel. The negatives cancel. 22 and 4 have a common factor of 2. So this becomes 11, this becomes 2. So I get 11/18 for one of mine. So here's one solution. So one of my x-intercepts is 11 over 18 and 0. There's my ordered pair. And to find the other one, I'll use a slightly different color here. And so I'm solving for this. Again, I subtract 3 from both sides, which is 27/9, giving me negative 4x is equal to negative 32/9. Again, same idea. Get rid of your multiplication of negative 4 by multiplying by the reciprocal. Those cancel. The signs cancel here. 4 goes into 32 8 times. So I have 8 over 9 as my other solution. So 8/9, 0 would be my other answer. Okay. Now, as you are working through this, you can use your TID9s as well. Again, I wanted to make sure you see how to do it by hand, but if you know how to use your TID9, it'll save you a little bit of time. Okay? As long as you understand the rules that we set out here. Okay? So if you take out your calculators, we'll go through how to find the intercepts here. And I'm going to show you several different ways. Okay? The first time I'm going to go through, I'm going to show you by finding or by using these the rules that we set up. And then second, I'll show you by just using the graph itself. It's your choice on what to use. All right, so first thing though, because I'm going to be using this equation for a number of different things, including looking at the sketch of its graph, I'm going to go ahead and enter that in my Y editor first. So if I hit diamond F1, that accesses my Y editor. I'll clear what I have in there, and I'm going to replace it with this equation. Okay? When I write that equation 9 times, remember, absolute value symbols are not these vertical bars. You access it by hitting the alpha key, locking it, and typing in ABS. Before you deselect the alpha key, you can put the whole expression, negative 4x plus 3, inside the absolute value is minus 5. And when you hit enter, just verify that it looks like how you were expecting it to look. Because when it displays it, it'll put it in the absolute value form that you will recognize. So 9 times negative 4x plus 3 minus 5. Okay, so you see that it's entered correctly. Once you see that, you can go back to your home screen. And just remember, you can call this up using the Y1 function notation. Okay? So if we want to find our y-intercepts, the first thing that we can do is we simply evaluate this at 0. Okay? So the way that you use function notation, y1 of 0 is going to insert a 0 everywhere there's an x in that expression. When we hit enter, it verifies that 22 was the correct answer. So 0, 22 is your y-intercept. Okay? And then the other rule was to find the x-intercepts, you simply set the equation equal to 0 and solve it. So on your calculators, what we can do is go into this F2 algebra tab, select solve. Okay, we can type y1 of x, set it equal to 0, comma x. We're telling the calculator we want it to solve for x when that equation's true. And that's going to give us our any x-intercepts. So we see 8 over 9 and 11 over 18 are both confirmed. And you would just need to understand that those are going to be written as order pair for the x-intercepts. Okay. In my opinion, this is the easiest way to do it. Okay. I mean, all in all, I wrote the equation one time. I had one line here to evaluate my y-intercept, one line to evaluate my x-intercepts, and I'm done. Okay. So I would recommend you do it that way if you're using your calculator, but I do want to show you, because it's a skill that we haven't talked about, to use your calculator's graphing tools to find the same kind of information. Okay. So when you enter your equations in the Y editor, they're also accessible on the graphing window, okay, or the graphing utility. So if you access the graphing utility here, hitting diamond F3, where it says graph in green. Oops. Okay, it pulls up your graph and displays it for you. Now, my window settings have changed here, so I do want to go through with you how to change your window settings and what the default settings should be. And if you come in here and you don't quite see the pieces of your graph that you want to kind of trace along, what you can do is you can access the window settings, which is diamond F2, again in the green writing window. And what that does is it allows you to change what the window that you're looking at. And the default settings for the window you're looking at are plus or minus 10. So I see that my minimum x is negative 10, my maximum x is 10. Those are my defaults. Then negative 10 for my y. I've changed this to 1,000, so I'm just going to change it back to 10 here. Hit enter. Once I hit enter, I can go back into my graph. So diamond F3. And this is the viewing window that, again, might be a little bit easier to see. Now, you might want to change it, but again, even within this, you're good. Okay. But if you want to change the window settings, you can. So if I know that this is a steep graph, so I don't need to see from negative 10 to 10, I might just want to see from negative 2 or negative 3 to positive 3, let's say. So if I go into my graphing window, my x minimum at negative 3, my maximum at 3, do the same thing, go back in and view it. Now it might be a little bit easier to see what it is I'm trying to look for. Okay. Now by doing this, I found my X-intercepts, but I've lost my Y-intercept, right? Okay. So, I mean, it's up to you how you want to change your viewing windows. Okay. If I experiment with a couple different values to see where is it that I can find, I still don't see my intercept here. So I'm going to go ahead and find my X-intercepts first, and then I'll come back and show you with the Y-intercept, and you don't actually need to see it anyway if you understand how it's calculated. Okay, so let's first find these X-intercepts. Okay, so I'm going to go back into my window setting and change it so that I get a little bit clearer view of my graph. So here are my two X-intercepts. Okay, they're not values that I can estimate from the tick marks. All I know is that they are less than 1. Right? One's pretty close to 1. One's a little more than half of, like a little beyond half. Okay, but that doesn't help you when you're looking for exact answers. Okay, now, if you are using the graphing window, it's going to give you answers in decimal form, okay, not fraction form. So again, as I mentioned earlier, I definitely recommend the first way that we do it, but if you want to use the graphs, you can. Okay, and if you go in and you want to find where these intercepts occur, you're going to hit the F5 Math tab, okay, and then you're going to hit zeros. Okay, if you hit 0, what it's going to ask you is it's going to ask you to set a domain for which you're finding the 0. Okay, the domain is they call it left and or a lower and upper bound. So the lower bound, you know you need this to be somewhere in this area, somewhere below 1/2. Okay, now you can just scroll along your graph. In this case, because you don't know what those decimal values are, it might be easier just to scroll. So if you scroll, the lower bound needs to be to the left of what you're looking for. Well, here's what I'm looking for right here, right? This value right here is what I'm looking for. So as long as my cursor's to the left of that, I can hit enter. That sets my lower bound. And now it gives me the choice for upper bound. Now I need to be to the right of this. But because there's two different intercepts here, I still want to be to the left of this other intercept. So if I scroll through, I can be anywhere. I can be here, here, even here. I can still be there. That's still, everything's kept to the left. But probably the best way to be is I'm below the x-axis and to the right of it. When I hit enter, it'll give me the coordinates of that point. So I see my answer is 0.611. Now, 4 times, remember this E represents times 10 to the power of. So 4 times 10 to the power of minus 13 is equivalent to what? I have 12 zeros, 0.00, 12 times, and then 4. What's that equivalent to? If somebody owed you 4 times 10 to the minus 13th dollars, how much do they owe you? Nothing, right? It's 0, right? So if you see e to some negative power that's a high number, it really is just another way of stating 0. So that is this value right here, or this one, the 11 over 18 is 0.611. And then if we want to find this second one, we can do the same thing. The F5 Math tab, select 0. This time I want my cursor to be somewhere to the left of this intercept. Again, but not to the left of this one, so somewhere in between these. So that's fine, that's close, but so this one for sure is there. My lower bound means to the left of. Okay, my upper bound, I just need to cross this x-axis. And again, the easiest way to find this when you're testing for the zeros is, did my y value turn positive here? So notice, can I use this point as my upper bound? No, my y still hasn't turned positive. Once I move to the next one, it does. So I can hit enter, and it gives me the intercept there, which again is 0.8888 repeating, which is 8/9, and then 4 times 10 to the minus 13th, which is 0. So that gives me those two intercepts. Once again, way easier to just solve the function, set it equal to 0, and those are your answers. Okay, now, the other intercept that you might need to find using your calculator would be the y-intercept. The y-intercept is pretty easy to find as long as you see in your screen where the x is 0. Even if the y is not actually displayed, if you go into this F5 Math tab and select value, value lets you just type in a number and it tells you what the output is at that input. So what's the input for our y-intercept? 0. So if I hit 0 here and enter, it shows me that even though I don't see it on the graph itself, it still shows me right here. So my answer would be 0, 22. Okay, but once again, taking f of 0 on your home screen is just as easy. And again, using that first method, way easier.